Hello, I'm Jagandra Muthukrishnan and I'm about to present the estimation and interpolation of this project. In order to get the ANOVA table and the regression table, I inputted the data into the breakup in which I choose the data option and then I choose the statistic option and then I choose the regression option in order to output the result. I use pressure and humidity as the x variable and temperature as the y variable. This in order output the results and the ANOVA table and the coefficients of the interpolation pressure of and humidity.
From the above table, I was able to get the coefficient of temperature and pressure and humidity, and I was able to create the regression equation from that, which is y equals to 186.21 negative 0.17 x1 plus 0.36 x square, which is y equals to predicted temperature, x1 equals to pressure, and x2 represents the humidity. The magnitude of the pressure is negative 0.17 and the magnitude of the humidity is 0.37. The pressure has a negative relationship with the temperature. Meanwhile, the humidity has a positive relationship with the temperature. Pressure is statistically significant compared to the humidity, which has a higher significant compared to the pressure.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi Aiman bin Muhammad Ali, and today I will be presenting section 4.2D of our project, which covers the statistical testing for our multiple linear regressions model predicting the temperature in IoT system. So, our regression model use two environmental factors to predict the temperature, which is pressure and humidity. So first, let's look at the overall F-test to see if our model is significant. So the result show the F statistic equals to 29.67, and this is much greater than our F critical value of 3.25. So for the decision, we reject the null hypothesis, meaning our model explains 61.6% of the temperature variance, which is quite good for environmental data. And now let's test each parameter individually, starting with pressure. So for the result, since our t value exceeds the critical value of 2.03 and p value is less than 0.05, we reject the null hypothesis. So next, we testing the humidity with t equals 7.21, much higher than our critical value, so we reject the null hypothesis. So to summarize our findings, the overall model is highly significant. Humidity has a strongest effect and the pressure has the moderate effect that shows the positive relationship and negative relationship. So that's all from me, and thank you.
Hi, Assalamualaikum. My name is Muhammad Fiyad Asma bin Faizal, Numeric ECE 30116. So for today, I want to present about the goodness of fit. So you can see the determination R square and the determination adjust R square. So firstly, R square, for the access simulation, you can see the liners for to get the data and then get the answer the 0.61. So the for manual calculation, you can see the R squared, the formula is 1 minus SHE divided SST. So we can get the 0.616. For the adjust R square, you can see when the same the manual calculation. So you can see the 1 minus 1 minus R square multiply the n minus 1 divide the n minus k minus 1. So can get the 0.595. So that R square is a value of 0.616. The modest the adjust R square value of 0.595. This is not the issue, not model, and this number is highly magnified. For the software R square and adjust R square. So first learning to must get the output at here. So must go the formula and then get the lineage. So first get the temperature and then pressure and humidity. So we can get the result at here. So we can get the R square and the standard error. So you know adjust R square, you will get the formula from him and then the get answer 0.59.
Hi, my name is Ridwan and I will talking about diagnostic checking, which is the purpose of diagnostic checking is to verify whether the multiple linear regression assumption are satisfied and to ensure the regression result are valid, reliable and not misleading. And first we can see that linearity check, which is this indicates a linear relationship between a predictors and temperature. The conclusion is linearity assumption is satisfied. And two is independence of error, which is the observation of were collected independently from the dataset. And the conclusion is residuals are independent. And third is homocedaticity, constant variance, which is the spread of residuals remains approximately constant across all fitted values. The conclusion is homocedaticity assumption is met. And fourth is normality of residual, and most residual lie close to reference line. And conclusion is residual are approximately normally distributes. And fifth is multi-collinearity check, which is variance inflation factor VIF values are within acceptable limit, which is VIF less than 5. The conclusion is no multi-collinearity problem exists. And overall diagnostic conclusions are all major regression assumptions are satisfied. The regression model is statistically valid, and the model is suitable for prediction and inference in IoT environment monitoring systems. That's all. Thank you.